We do have a few definitions that we need to talk about, and then we're going to be able to come up with a few formulas. Formulas can make things a little bit easier for us, but we first have to understand this word mutually exclusive. For something to be mutually exclusive, it means that they cannot occur at the same time. So two events that absolutely cannot both happen would be mutually exclusive. So take a look at example 5.7. We know that 30% of the calls to emergency 911 number are for medical emergencies and 20% are not considered emergencies. Now there's plenty of other types of calls. So we can think of what's going on in this problem. You have your medical emergencies and you have your not medical emergencies. And then we have your emergencies and your not emergencies. So we still would use a hypothetical table. So labeling this one's a little bit tricky. So what I'm going to do is put some words along with this because otherwise I get really confused. So we have our medical emergencies and our not medical emergencies. So medical emergency and a not medical emergency. Okay, there's plenty of things that you would call 911 that were not a medical emergency. And then we have our non-emergency calls, so that's going to be our N. So these are non-emergency. And then we're going to have our not N. This is where it gets a little confusing. It's a not non-emergency. So let's just call that an emergency. So let's look at the information that we were given. We were given medical emergencies and we were given things that were not considered emergencies. So the not emergency was 20%, so that's going to be 200 with our hypothetical 1,000 table. But then let's think about a medical emergency and a non-emergency. How can you have a medical emergency that's not an emergency? Okay, it's not possible. So this first box right here would be two events that are mutually exclusive. You cannot have a medical emergency without having an emergency, so there are no observations that will go in that particular box. The medical emergencies are all going to be emergencies, so these 300 calls will actually go right there. So we have a total 300, and now we can work backwards. I know that there's 0 non-emergency medical emergencies, which means that there are 200 calls that are not medical emergencies. Well, what about the rest of them? Well, if we've accounted for 200 of the calls, that means 800 of the calls are going to be emergencies. And that also tells us then that there will be 500 emergencies that are not medical. And now we can add those across and get 700. So we have our table, and now getting the probabilities is just looking at the table. What's the probability of M and N? Well, that's 0. There's none that are in both of those groups. Now, what's the probability of M? That's 300 out of the 1,000, and you can write that as 0.3. The probability of N, that's 200. And hopefully you've noticed when you have just one letter, you're usually looking at the total of a row or the total of a column. And then finally, the probability of M or N. Here I want all of the M's or N's, and that's going to be all 3 of those. So that adds up to 500 over 1,000, which equals 0.5. I want you to notice something. We had 2 mutually exclusive events. It didn't make sense to have a medical emergency and a non-emergency. So those 2 events were mutually exclusive. And then we find 2 very useful things. The probability of the AND must be 0, And the probability of the or happens to be the sum of the two events. And that is not an accident. That will always happen. So the addition rule for mutually exclusive events is going to go something like this. So if E and F are mutually exclusive, the probability of E and F will always be 0. And the probability of E or F will always equal the probability of E plus the probability of F. Now, if you remember back to some of the other tables that we did, when we were looking at the ORs, we had to make sure we didn't overcount that intersection box. Well, there was nothing in that little intersection box, so you don't have to worry about any overcounting here. So these mutually exclusive events make something a little bit easier for us to calculate the OR problems.